So I'm going to talk about how to use some tricks that wholesale network providers might give us to optimize traffic delivery. For those of you who don't know me, my name's Marek. I founded and the CTO at Faelix. I'm one of the PC program committee at UKNOF, and I'm one of the crew at Net Manchester. Faelix, we are a small company. There's just a few of us, mostly network engineers. We're a silver partner on LON 1, LON 2 in Manchester. We help altnets, in particular, people building out fiber or fixed wireless access to get their network infrastructure in tip-top working order. And we offer some various bits and pieces to make that happen. And you can tell if you're in a data center where we've got presence because you'll find our SSID blasting over the airwaves. So as I said, this talk is aimed at access providers or people who've got traffic that's mainly coming into their network. People who are consuming wholesale national Ethernet or L2TP type broadband services, and ideally networks who've got multiple sites where you've got peering and transit. So as an example of one of those, I'll sort of use ourselves from a few months ago. You've got some BGP routers in the north and in the south. There's some sort of a backbone connecting the two via some diverse paths, for example. And you've got bunches of customers in some shape or form, whether they are a leased line to a customer, or maybe it's some access out to an FTTP network. And they might connect into one or maybe more of your POPs. At those POPs, you might have some transit. You'll be connected to some internet exchanges. So I'm going to use LINX Manchester and LON 1 in this example. I'm not going to talk too much about the tricks we use for transit, but they are very, very similar. And ultimately, there is some content that your customers are trying to access. And some of these content delivery networks that have this hosted, they might be connected to more than one of the IXs you're present at. And a typical sort of traffic flow that you might be seeing is, well, there's some traffic coming in from LINX Manchester towards some of our customers. And there's quite a lot more traffic coming in from LON 1 towards our customers. And that's great. But some of that traffic from Manchester ends up going down to customers that are connected in London. And some of the traffic from London is coming up to Manchester over our backbone to get to our customers connected up there. If we were mainly sending traffic outbound, we could do some traffic engineering. We could dump out transits in the nearest POP, for example. We tend to find that a national internet exchange like LON 1 and to a lesser extent LON 2 very much dominate the traffic that we receive compared to the regional IXs. So how can we try and optimize that if we can? And one of the challenges this brings is that you end up having to build backbone capacity roughly equal to the size of your LON 1 ports, which can make some networks think, well, why did we bother building outside the capital when we could have just got more transit in a regional location? Or how do we retrofit the capital into a network that used to be just regional? And hopefully I'm going to answer some of these, or at least show some of the tricks that we're using. So how do content networks work? And I'm just going to very quickly cover that. I'm going to make some assumptions about how they work because quite a lot of this is their secret sauce, and it's tied up in patents and all sorts of intellectual property rights. But very roughly, the way we seem to see it work is your eyeball user makes a DNS query, which hopefully is going via your own resolvers, and it queries the content delivery network's DNS servers. They tend to respond with something that is nearby as an A record or a quad A record. How they do that, how they choose what to respond with, tends to be where their secret source is. And they'll use a mix of technologies, some of it Anycast, some of it GeoIP, and probably lots and lots of their own information gathered from their control plane. So a typical example, we're here at the top in the middle. We're connected to a couple of IXs, and the CDN will have a range, probably that they've got their DNS servers in. So here it is, 192.0.2.0. And they'll be announcing that out of both or even all of their POPs. Some do it on a regional level, some do it on a country level, some do it globally. But fundamentally, we see quite a lot of them are using Anycast to host their DNS. And when you make a query to their Anycast DNS servers, they'll reply usually with a unicast response, which tends to be a prefix that is announced from where you actually queried. And so you'll tend to find you might see slightly different prefixes or maybe different meds, depending on how the network works, from different IXs. And the idea behind that is, for long-lived TCP flows, you don't want that going over UDP. You may have problems with Anycast, TCP over Anycast, so they tend to send you a unicast IP. Now, part of the inspiration for my talk comes from Thomas Mangin's LINX 96 talk, which was about how to use DNS resolvers. And one of the tricks he talked about was to potentially announce more specific /24s from some of your POPs. The idea being that the CDN sees your traffic from that /24 as being really, really localized. Be aware, though, that not all content delivery networks will receive, if you send them one /24 to, for example, Manchester, their nodes down in London might not actually receive that route, and they might only receive your aggregate. So this won't completely solve your problems. And it does help to a degree. You'll start getting traffic coming from Manchester going to your customers in Manchester, and it doesn't really help with traffic from London traversing your backbone where that IX, where that content network is only present in London. So you're still going to end up hauling traffic up and down the country. Is there anything we can do about that? Well, I'm now going to talk about some of the national Ethernet services, which very roughly are, you buy what feels like a leased line from a wholesale provider, and they hand off that as a layer 2 service back to you on an NNI, a network interconnect at your data center. And one of the things they then started marketing in the last few years is the ability to hand off that leased line on 2 NNIs. The idea being you might want some resilience in your network. And the way they do that is, if you look over at how it hands off to the customer, is they provision 2 VLANs over there, and they provision a different VLAN on each of your NNIs. And so now you sort of have a customer to 2 points within your network. And they call this the shadow VLAN. Is this any use to us? Well, it turns out that most of these wholesale networks, like SSE, now called Neos, TalkTalk, Virgin, and others, they market this for resilience. But when you actually dig into it, they don't actually vary their pricing depending on which NNI they are going to deliver this customer's traffic on. Which means they've basically baked in the cost of hauling the traffic up and down the UK, regardless of where they're presenting it to you. So whether we take our Scottish customer into Manchester or into London, the cost's the same to us. And in fact, if we take a customer in Manchester into Manchester or London, we still end up paying SSE or whoever roughly the same amount of money. It's actually exactly the same amount of money. And it turns out you can use your shadow VLAN for carrying production traffic alongside the main VLAN. So why not use both? So the challenge here is, rather than hauling traffic up and down our own network, can we instead use this capability that the wholesale networks are providing us? So now the idea is connect your customers to both of your sort of main POPs, so Manchester and London in this case. And now you can get traffic from your CDN in London to your customers in the north via your NNI down in London. And you're not actually having to transport it up your backbone necessarily. And so the net result ends up being more like this. A lot less traffic ends up going up and down your backbone, and instead you are using the flexibility that your wholesale provider offers you to try and offload some of that. Now, there are still some tricks going to need to be played, because the CDNs are still using their Anycast DNS stuff, and we're going to have to somehow steer traffic to make best use of our regional peering where an IX is available in more than one place. So we're actually going to talk a little bit more about Anycast and how their DNS tricks are working within the CDN. Within our network, in each of our main sites, we have got a local DNS resolver. And that DNS resolver sits potentially within a more specific /24 that we announce to that CDN in those locations. And the idea behind that is we're doing the reverse of what the content networks are doing to us. We are similarly, just as they are announcing a DNS their DNS authoritative service over Anycast, we're going to end up using Anycast within our network, sort of in reverse. So a query goes to our resolver asks from its unicast address within that POP, please could you give us a record, and back comes a unicast IP. And similarly, if a query ends up going to one of our other POP sites, the unicast request for the DNS A or quad A comes from something that is quite local to that POP. And as a result, we can sort of steer which way our traffic will end up coming by which DNS service within our network ends up being used. The question is, which one do we choose? You may have a preferred IX. So for example, you might have peering with, let's say, Limelight in both Manchester and London, and you might want to see more traffic on your Manchester port. So you'll want to prefer sending DNS queries to Manchester, for example, with the aim of attracting traffic to come from Limelight on IX Manchester. One way you could do that is just by lowering the prefs or adjusting your meds so that your resolver in London, for example, is less well received by this customer. And so effectively London becomes a second option for that customer. But this poses some other challenges, like, do we actually even have enough /24s? Some of the small networks that we deal with are, quite recent entrants into being an access provider. And how do you automate all of this if you're actually a much larger operator who has a plethora of IP address space? And how do you make sure that the right 24s go to the right places? And maybe that's not even possible because you can't retrofit that into the way you've done your IP address allocation. So this now comes to the sort of main point of this talk. Instead of using our shadow VLANs and main VLANs to just propagate a default route, what if we start selecting golden subnets, networks that we receive from our peerings on internet exchanges that we want to be able to help steer to our customers to be able to steer their traffic to better? And the way we do that in our network is we're already using Bird for root servers within our network. We have a root server in each POP. And what we do is we have a set of filters that we use for announcing to CPE, controlled by us, nearby prefixes that are what we call golden. So CDNs or sometimes big destinations. So if it's going to be a heavy amount of outbound traffic, we'd like to get that off our network where we've got the most capacity for the best cost. So again, we might want to try and steer that towards our regional peering if it's available. How do we decide what's golden? Well, we've got a simple set of rules, which basically is it a network we see in our top 20 destinations in our AS stats? Or is this a network that we see on more than one internet exchange? And at that point, we might consider that golden as an ASN or as a prefix, and we'll incorporate it into this scheme. A very, very simple example of how we're doing that filtering. This is including the SALT templating that we use. Basically, it's a golden CDN if it's in this list of CDN AS numbers, and that's basically it. And which IXs are nearby to a particular POP? Well, we've got a list of prefixes for those IXs peering LANs. So those are the ones that are near the root server. Those are the ones that we're going to want to try and steer as well as we possibly can to customers connected at that POP. We have a very, very simple Bird configuration for this, templated out. We try and separate the rib and the fib on our root servers. We want this to be a bit like a root server, talking over eBGP. And the magic is that little filter there. And here's an example config from one of our actual routers. And I'll come back to what this thing here is because it's the second part of the talk, effectively, or the last part of the talk. Is this working? Well, here is a customer site connected via exactly this technique. So this customer site receives about 3,000 V4 and about 2,500 V6 prefixes. And as a result of that, we're seeing almost, it sort of feels, looking at that graph, about the same amount of green and blue traffic, which corresponds to London and Manchester. And in fact, if you look at the amount of overall bytes sent from each POP, it's almost exactly 50-50 over the last 7 days since I wrote these slides. So we're managing to balance our traffic quite well across Lon and Manchester. Which brings us on to, well, what if we're not using a technology like National Ethernet? What if we're consuming FTTP services? Things are a little more complicated there, but one of the reasons why you might want to do this is we actually sell transit on both leased lines and FTTX type services to help altnets build out their backhaul. And it's great when you can get FTTP 1000 somewhere and are prepared to use that, for example, as a backup path. But if you can't, what potential options do you have for getting more traffic? Once upon a time, everyone was using MLPPP for this, multi-link, but we're not experienced with all of the issues that you can have with CPE and BNGs and LNSs. We're sort of more data center experienced. So is there something that we can do with what we've learned from our tricks with shadow VLANs and National Ethernet? And I'll just give a very quick overview of how that fits in by explaining a little bit about how wholesale broadband works. So let us say we're going to connect one of our customer sites via multiple broadband type services, and they're going to come into our wholesale provider. I'll use Zen as this example, and that's going to hand off to us on an LNS via an NNI. Well, potentially we'll want more than one NNI because we want some resilience, and we're trying to do these tricks. So maybe we want to order more than one NNI, one in Manchester, one in London. And it turns out Zen's network is a little more complicated than that because they also have, as far as we can tell, a lot of BT wholesale services which hand off to them in London. And they obviously have their own backbone. So very roughly, the sort of overall architecture looks a bit like this. And now this starts to lend itself quite well to the idea of, what if you order one on-net service and one off-net service from Zen? So they provide to us one that's from BT Wholesale and one that's on their own network. And I think you can see where this is now going. Because what we want to avoid is traffic coming via BT Wholesale to Zen, up their backbone, to us in Manchester, to reach an LNS down in London, to go out in IX Manchester, for example. Now, there's a quick fix for that, which is apply some meds, and now you can at least get your traffic to your London LNS. But how do we try and steer traffic to come in from Manchester down a link in Manchester rather than hauling it over our backbone now? And how do we make sure that we can use that Manchester link more effectively as well as using the London link more effectively? Well, that's the next trick, and it's basically using exactly the same BGP techniques I've already described, only with some FTTP and FTTC involved. So the way it works is a PPPoE session comes into a LAC, we get an access request to our radius servers, and there we can respond where we want it steered to with an access accept, and that then informs where the L2TP session comes into from our wholesale provider. And at that point, we have established a point-to-point link between a specific LNS and a customer site. And we added to our radius setup the ability to, at the customer end, or at least on our managed router at the customer end, be able to steer which LNS a particular connection comes into by just adding a plus something to the username. And as a result of that, we can change this sort of mess of connectivity to something that makes it a little more sensible for the kind of traffic engineering we're trying to do, which is to keep traffic from the south using paths we've established in the south, and similarly in the north, and not use too much of either Zen's or our own backbone to transport this traffic around. Going back to what this thing was that I mentioned in an example in Bird, that is exactly what we're doing with a couple of virtual LNSs in Manchester and in London. And it's that box there in this instance. And what this is doing is we're teaching the LNSs here the actual set of prefixes that are local to the north or local to the south. And using that, helping steer which way the DNS queries end up going, and hopefully helping steer which way the traffic then comes in into the network and gets routed over the tails to the customer. And the nice trick about the fact we're using BGP for our connection from the customer's router through to our LNSs, and our LNSs are learning over BGP to the local prefixes, is that adding more bandwidth is just a case of adding more paths. Because here we can actually apply equal cost multipath on our BGP sessions and make use of aggregate bandwidth, which I find much more simple than dealing with MLPPP. And an example from a couple of days ago is a customer site here with 4 connections where we're getting pretty even distribution of traffic overall. Here, I don't know whether they were torrenting something or downloading something from a CDN, but overall, they were basically using all 4 links to full effect. Looking over a 7-day period, it's not quite as even for whatever reason. This is actually a smaller site, so it might just be down to lack of data. But that chunk there, roughly 1/3 of the traffic, came from Manchester and just went over links that notionally terminate on our LNSs in Manchester. And so that was traffic that didn't go over our backbone, or indeed that we had to, capacity plan for in terms of both our peering and our layer 2 backbone. So in conclusion, analyze how DNS resolution is affecting which POPs a CDN sends you traffic. I mean, that's the beginning to this. And with that, you can start to use multiple physical or logical connections, so Ethernet or L2TP type services, to both add resilience, because both sites can still provide full transit and routing and so on, but also the benefit of improved traffic routing from CDN traffic to the customer side. Why bother with this? Well, it helps keep traffic local. Potentially, you can lower latency with this. Potentially, you're reducing traffic tromboning over your backbone, your wholesale provider's backbone, and the like. It helps you use regional internet exchanges, which tend to have lower port costs. It spreads the load both for you in terms of your peering ports, but also for the CDNs. And it helps attract CDNs to other regions as well. And of course, it improves resilience. It means you can survive a single POP outage or a single internet exchange outage much better because you're already connecting customers to more than one location. And that is the end of my talk. I'm very, very happy to take questions about what we're doing and how we're doing it. And I'll hand it back to you, Jeremy.